is based on Poisson distribution. So it is an extension case of binomial distribution. If n is 2 means we will use binomial. If n is large, that is the evolution of the binomial probabilities can involve complex computations. So in this case, we will use Poisson distribution. Poisson distribution occurs when there are events which do not occur as a definite number of trials, but an event occur rarely, and the following examples will be analyzed. For example, number of bacteria in 1 cubic centimeter, or number of printing mistakes per page in a textbook, number of alpha particles emitted by a radioactive substance in a fraction of a second, or number of road accidents occurring in a particular interval of time per day. Let us discuss about the definition. A random variable X is said to follow a Poisson distribution with parameter lambda if it assumes only non-negative values, and its probability mass function, because it is a discrete case, the probability mass function is given by P of X is equal to X, that is equal to e power minus lambda power X divided by X factorial. Here X is non-negative, right? So X varies from 0, 1 to etc. and lambda greater than 0 and 0 otherwise. Next, we will calculating the moment generating function of the Poisson distribution, that is equal to expected value of e power t. So which is calculated as summation e power tx into p of x, right? So substitute the values here, and finally we get t is equal to 0. We get the moment generating function as e power lambda into e power t minus 1. Next, we will find the mean and variance. So mean means we have to derivate the moment generating function one time, and variance we have to find e of x squared. No, e of x squared means we have to differentiate the moment generating functions 2 times. So these are the final values. And next, substituting the variance equation, we get the variance as lambda. So the mean and the variance of the Poisson distribution both are lambda here. Coming to the problem, assuming 1 in 18 words is a case of twins, calculate the probability of 2 or more sets of twins on a day when 30 birds occur. So here X denotes the set of twins on a day. So probability of 10 twin birth is, assuming 1 in 80 birds, it is 1 by 80. And n is equal to total 30 birds. What is the lambda? Lambda is n. So 30 into 0.0125, that is equal to 0.375. Here X follows the Poisson distribution. Poisson distribution. So we will use the Poisson formula. Here lambda value we will know, right? We have to substitute here. Next, we have to find the probability of 2 or more. So what does mean by that? It is also the probability of 1 minus probability of x equal to 0 plus probability of x is equal to 1. So we have to substitute x equal to 0 and x is equal to 1 in the binomial in the Poisson distribution formula. Finally, we get the answer as 0.055. Next, we have to find the Poisson distribution variance such that P of x is equal to 2. That's a relation, something relation is given. Next, we have to find the mean of x, that is lambda value we have to find. So Poisson distribution formula is given here. So in this relation, we have to substitute the x value as 2, 4 and 6. So finally, we get expressions for lambda, and solving this expression, we get the lambda value as -4 and -1. But we already know that lambda is greater than 0. So we will omit -4 and we will get the lambda equal to 1. So we know that for Poisson distribution, variance is also equal to lambda. Its value is equal to 1. Next in this problem, in a book of 520 pages, 390 typographical error occurs. Then what is the lambda value? Lambda is the average, no? So 390 divided by 520, that is equal to 0.75 was the average number of typographical error. Assuming Poisson law for the number of errors per page, find the probability that a random sample of 5 pages will contain no error. First, we have to find it for single page. And finally, we get multiple the probability answer with 5. Okay. So here, lambda is 0.75. The question is about no error. No error means what's our x value? X value is 0. So substitute the x value in the Poisson distribution. We get the answer as e power minus 0.75. But the question is about there was no error for 5 pages. So we will multiply this probability for 5 times. Otherwise, we will simply write it as e power minus 0.75 whole power 5. So the final answer is e power minus 3.75. The next problem, an insurance company has discovered that only about 0.1% of the population is involved in a certain type of accident each year. If it's 10,000 policy holders were randomly selected from the population, what is the probability that not more than 5 of its clients are involved in such an accident next year? Here, probability is 0.1 divided by 100 because 0.1%, so p value is 0.1 divided by 100. Next, n is 10,000. So using these values, we will calculate the parameter of the Poisson distribution. Lambda is 10. Next, we have to find the probability distribution function, which is not more than 5. Not more than 5 means the expression is x less than or equal to 5. So we will calculate for x equal to, from x equal to 0 to 5. So substituting the Poisson distribution formula, we will get the final answer. In our next problem, 1/4% of the blades produced by a blade manufacturing factory turn out to be defective. The blades are supplied in packets of 10. Use Poisson distribution to calculate the number of packets containing defective, one defective, and two defective blades, respectively, in the segment 1 lakh packets. So the p value is 1/5 percentage means 1 by 5 whole divided by 100. So n value is 10. So lambda is 0.02. Substitute here. So first we have to find it for number of packets containing no defective means its value is 0. And next we will calculate for x value containing 1 means n into probability of 1. So in the Poisson distribution, take the x value as 1 and calculate the answers. And finally, we have to find the number of packets containing 2 defective means x is equal to 2. Substitute in the Poisson distribution expression, we get the answer as 20. And in the next problem, the number of monthly breakdown of a computer is a random variable having a Poisson distribution with a mean equal to 1.8. Mean means lambda. Find the property that this computer will function for a month. Without a breakdown means x is equal to 0. With only one breakdown means x is equal to 1. Substitute here and get the final answers. In the next problem, in a large segment of electric bulbs, 10% are defective. That means P is equal to 0.1. A random sample of 20, that means N is equal to 20. Find the probability that all are good bulbs, or all are good bulbs means here it is a defective. So all are good bulbs means x is equal to 0. Substitute in the Poisson distribution, we get the answer as e power minus 2. What about the next one? Exactly, there are 3 defective means capital X is equal to 3. So in terms of small x, substitute the value as 3 and calculate the answer. So the final answer is 4 into e power minus 2 divided by 3. Probability of at most 3 defective means the symbol is p of x less than or equal to 3. So we will calculate it for x equal to 0, 1, 2, 3 and find this probability and add all these values, we get the final answer. In the next problem, if the probability that an individual suffers a bad reaction from injection of a given serum is 0.001, determines the probability that out of 2000 individuals, exactly 3 and more than 2 individuals will suffer a bad reaction. So here we have 2000 individuals. So n is 2000. That will be the probability that an individual suffers a bad reaction, that is 0.001. Then what is Q value? It is 1 minus P. Using these values, we will find the parameter of the Poisson distribution. Lambda is equal to NP as 2. First, we have to find the probability of the 2000. Exactly 3 will suffer a bad reaction. It's capital X is equal to 3. And out of the more than 2 individual means, what is the notation? Probability of X greater than 2. This will also be rewritten as 1 minus probability of X less than or equal to 2. So this expression can be rewritten as X is equal to 0, probability of X equal to 1 and probability of X equal to 2. Substitute these X values in this Poisson expression, we get the final answer as 0.323. And the next problem, the atoms of a radioactive element are randomly disintegrating. If every gram of this element on average emits 3.9 alpha particles per second, what is the probability that during the next second, the number of alpha particles emitted from 1 gram is at most 6, at least 2, at least 3, and at most 6. Here, our expected value is 3.9, that is mean NP is equal to 3.9. Then what about P? It is 3.9 divided by N. Here N is very large and P is very small. So hence we have to take a very close approximation. X follows a Poisson distribution with the visible parameter lambda is equal to 3.9. Substitute here. The first problem is based on they are asking about at most 6. That means X less than or equal to 6. So take the X value. Here we have taken the summation, no? That means we have to add all the values of the probability mass function for n equal to 0 to 6. Next, probability of x greater than or equal to 2 means we have to subtract 1 minus p of x equal to 0 minus p of x is equal to 1. Next, we have to calculate the probability mass function for random variable x lies between 3 and 6. So we will substitute in the Poisson expression. We get the final answer as 0.646. Thank you.